Hey guys, how's it going? Okay, my next lesson is on other functional groups present in organic compounds. Okay, so if you look at my last lesson, I talked about alkanes, which are single bonds, hydrogen and carbon, and sometimes there's branches off of them. Well, you know what we're going to be dealing with? We're going to be dealing with alcohols, carboxylic acids, esters, halogenated hydrocarbons. Okay, that would cover the rest of organic chemistry. And we are going to start on page right here, 49, halogenated hydrocarbons. Okay, now halogenated hydrocarbons, okay, that name, halogenated hydrocarbons, like it sounds like it's a hard name, but when you're talking about halogens, okay, you guys have to remember your periodic table that you learned about in Science 10, okay? So these are your halogens. Group 17, if you're part of this vertical row, you are called a halogen. Okay, so the halogens are fluorine, chlorine, bromine, iodine, and astatine. Those are your halogenated hydrocarbons. Okay, now you got to name them. Okay, now note that they have halogens, which is the group 17, but they're also hydrocarbons, meaning they contain hydrogen and carbon. So you know it's a halogenated hydrocarbon because they have hydrogen, carbon, and they have halogens. Okay, halogens. So we're going to name them. When we name them, what is really important for you guys to know actually before I name them is what we use halogenated hydrocarbons for. Okay, so halogenated hydrocarbons are used when we burn garbage. Okay, they're found in PCBs. PCBs, dioxins and furans and DDTs. We're going to talk about all these things. Dioxins and furans are formed after during the paper and pulp industry, like to bleach your paper, to make the paper like white, because the paper came from trees and trees are like, the bark is dark brown. So when you bleach the paper, you release halogenated hydrocarbons. Okay, DDT is a pesticide, so pesticides, halogenated hydrocarbons. We're going to talk about PCBs, which are found in clothing that make them look vinyl. That also contains halogenated hydrocarbons. Okay, not good for our planet. Halogenated hydrocarbons. We're going to talk about the one that's really important called CFCs. Okay, which you might have heard about before, which are like destroying our ozone layer. Those are halogenated hydrocarbons. Halogenated hydrocarbons are called POPs, meaning they're persistent organic pollutants. Okay, and that means they persist in the environment, meaning they're really hard to break down. They're like those benzene rings that I showed you before in my last lesson. So it's really important that we really moderate the amount of CFCs or any kind of halogenated hydrocarbons we release into the air, because it has a direct effect on us because it's persistent, and if it enters our body, it's not good for us either. Okay, so when we talk about halogenated hydrocarbons, right, we're going to talk about naming them, and they have 4 examples here. 1, 2, 3, 4. Okay, let's name this. Okay, so if you take a look at this, C, Cl, H, Cl, Cl, like that. I take a look at this and I'm like, okay, is this a halogenated hydrocarbon? Well, I think it is, because it contains halogens, group 17. It contains a carbon, and here's my hydrogen, right? It's a halogenated hydrocarbon. Okay, now if I was to name this, remember you got to name your parent chain first. And if you name your parent chain is always your longest carbon chain, like I said before. Well, hey, if I take a look at this, there's only, guess what? 1 carbon in the chain. So because there's only 1 carbon in the chain, I take a look at my table here and I say, okay, what's the name for my one carbon in my parent group? Oh, it's methane. Okay, so the name of the parent chain is methane. Okay, so that's step one, name the parent chain. Sorry that it got blurry there. And so I did, and the name of the parent chain is methane. Now I gotta name the branches. Okay, now what are the branches? This is a branch, this is a branch. Well, actually, no, that is not true. Hydrogen is never a branch, okay? This is not a halogen. The branches are the halogens, okay? So these are the branches, and I see 3 of them. Okay, so how would I name that? Okay, so you would name it. You don't use the YL this time, okay? Watch. You would name this 1,1,1-trichloromethane. Okay? 1,1,1-trichloromethane. Tri means I have 3 chlorines, chlorine, and it's found on the parent chain, which is methane. Okay, so that's how I named this halogenated hydrocarbon. Okay, let's try another one. So the next one they give you is this one. Okay, so it's C, Cl, F, Cl, Cl. Okay, how would I name this? Well, you gotta name your parent chain first, which is the longest carbon chain. Again, there's only one carbon, that's the longest carbon chain. So I say, okay, the parent chain is called methane. Okay, and then I name the branches. Okay, so let's take a look at the branches. This is a branch, this is a branch, this is a branch, this is a branch. Okay, so how would I name the branches? Okay, now you know it's a halogenated hydrocarbon because there's halogens attached to a carbon. Okay, so, well, you would name it as 1, 1, 1. Okay, like watch, 1, 1, 1, trichloro. And then, sorry, the name is long, 1 fluoromethane. So you can see that I named it trichloro because I have 1, 2, 3 chlorines attached to the methane, which is my parent chain. And remember, the parent chain always comes last when you name the whole thing. You always name the branches first, and then you always put the branches, the name of the branches first, and then the name of the parent chain last. You can see that I have 1, 2, 3, 1, 1, 1, 1. You see this chlorine, this chlorine, this chlorine, all on the number 1 carbon, trichloro, 1, 2, 3 chlorines. Okay, then I put a 1 here because the fluorine is also on the number 1 carbon, and I call it fluoro. Notice I don't put monofluoro because you only have 1, you don't need that mono, methane. And there I named that too. Okay, so for example 4, you can see there's 2 carbons, so the parent chain would be ethane, and the name of that, right? You can take a look at your PowerPoint. It's filled in for you on Schoology and on Google Classroom, and you can try that on your own and see if you get it right. Another thing that you guys got to know is practice diploma questions. And actually, PCBs here, I think PCBs actually are not found in clothing. I think they're actually found in transformers, which is electrical equipment. So I gotta fix that, just fix that. So that's where PCBs are found, sorry. Okay, anyways, biomagnification is something that you guys gotta know, and it's a really easy concept. And so let's say you have all these let's say you have all these PCBs in the ocean, okay? Which is like a persistent organic pollutant, meaning they persist. So let's say this is like the ocean, and each one of this is a PCB, right? You can see that in the ocean, right? You have all these PCBs. Let's say one fish ingests this PCB, one fish ingests this, one fish ingests this, one fish ingests this, right? You can now see, okay, if these fish ingest these, it's accumulating, right? This pollutant, this PCB is accumulating in their tissue, right? Look, oh my God, now they have all these pollutants, right? So what happens if, okay, an even bigger fish eats all of these fish? Well, wouldn't this bigger fish accumulate even more toxins? You can see each one of these small fishes only had 1 unit of toxins in each of their body, but when this big fish eats them, this big fish now has 4 of these units in its body, okay? So this is called biomagnification, okay? Or biological amplification, and that's what this is talking about. And then the last part is about ozones and layer and CFCs, and I'll be done this lesson. So basically what they want you to know is that here we live, okay, this is the troposphere, okay, above us is the stratosphere, and I talked about this in my last lesson with photochemical smog, but this is where ozone is found, is in the stratosphere, okay? So if you look on the ozone, O3 is ozone, it looks like this is ozone, okay? Now each one of these, this is O1, 2, 3, this is O3, okay? Now, when we release CFCs, which is chlorofluorocarbons. So what does that mean if you're a chlorofluorocarbon? That means you have a carbon and a chlorine and a fluorine, and like you look at this, you have chlorines and fluorines, right? Attached to your carbon. That's a chlorofluorocarbon. And you guys, you find this in your fridge, right? In air conditioner, in styrofoam cups, release chlorofluorocarbons. In fact, they ban them because when chlorofluorocarbons, okay, if they come up into the air and they go into this stratosphere, the chlorine pulls the oxygen away. See that? Pulls the oxygen away. So now this O3 becomes O2. And if O3 becomes O2, then the UV radiation is allowed into the earth. Because this O3 blocks the UV radiation, okay? The O3 blocks it. And so it can't come in, harmful UV radiation. But if you're O2, you don't block it and the radiation comes in, right? So you don't want to destroy the ozone layer. You need the ozone layer. You need the ozone layer to take all this UV rays and block it, right? O2 can't do the job. So they banned CFCs, and now we're starting to see the ozone layer kind of regenerate, come back to us a little bit, which is a good thing. Okay, so there you go. That is that lesson on chlorofluorocarbons and halogenated hydrocarbons, and how to name them, and hopefully that helps, and hopefully you know how to do that. So I'm gonna do the last lesson, which is gonna be on alcohols and esters, and then we'll be done organic chemistry. Okay, pretty much done organic chemistry.